Okay, so we were on question number 11. We were just about to rearrange our potential difference equation, which is equal to energy over charge, where the energy is kinetic, so 1/2 mv squared, to get our speed. So multiply both sides by q, multiply both sides by 2, divide both sides by m, and that will give you v squared. So v speed squared then will be 2. Our q was 3.204 to the negative 19 coulombs. Our voltage, our potential difference was 1,000 volts, and our mass was 6.7 times 10 to the negative 27 kilograms. Remember, that's going to be velocity or speed squared. You then need to take the square root of it. And when you do, you should get a speed, I think, of 3.0926, and then a couple other zeros and a 7, times 10 to the 5th meters per second. Once you have that, now you can come over here and find R. So 6.7 to the negative 27 kilograms times that 3.0926 to the 5th meters per second, divided by 3.204 to the negative 19 coulombs, and 6.5 to the negative 2 teslas. And when you do this, you should get an R of, just trying to decide if of 9.9493 times 10 to the negative 2 meters. So not quite 0.1 of a meter. Yeah, okay. So that's number 11. Number 12 says, where's the edge of my page? An electron. So it's an electron, which means its Q is 1.602 to the negative 19 coulombs, and it means its mass is 9.109 times 10 to the negative 31 kilograms. So they don't have to tell you that, they assume you know that. Is accelerated by 4.5 kilovolts or 4,500 volts. Your one probably just has the volts. Potential difference. How strong a magnetic field must be experienced by the electron if the path is a circle of radius 5 centimeters? So 5 centimeters or 0.05 of a meter, and it's asking for B. So if we go to R equals mv over qb, you'll see that we have an R, a mass, a Q, but no speed again. Instead, we have a potential difference. So again, we have to go to V is equal to E over Q. So V is equal to 1/2 mv squared over Q. So again, multiply by Q, multiply by 2, divide by M. V squared is equal to 2qv over M. So 2 times 1.602 to the negative 19 coulombs, 4,500 volts, divided by 9.109 to the negative 31 kilograms. And remember, that's going to be V squared. So punching in here, I just can't see when I put it there. 3.204 to the negative 19 times 4,500 divided by 9.109 to the negative 31. Take the square root. So you should get a speed of 3.9784798. So I'm going to put a 5 here, times 10 to the 7th meters per second. This time we want B, so we need to rearrange this. It'll be mv over qr. So B will be equal to M, which was 9.109 to the negative 31 kilograms. The speed is your 3.9785, but of course you kept all your decimals in your calculator, divided by 1.602 to the negative 19 coulombs, and your R 0.05 meters. Don't forget to change it from centimeters. So times 9.109 to the negative 31, divide by brackets 1.602 to the negative 19 times 0.05, close your brackets, and you should get 4.52434 in case you want to know the rest, times 10 to the negative 13 Teslas. That is number 12. Number 13, which is the last one I asked you to do for this set, says a mass spectrometer yields the following data. For a beam of doubly ionized means Q is going to be 2 times 1.602 or 3.204 to the negative 19 coulombs. Doubly ionized sodium atom, I can't see because it's too far away. B is equal to 8 to the negative 2 Teslas. Q, all they gave us, R is 0.077 meters. Voltage, 156 volts. And it says calculate again the mass. Okay? So again, if we go R equals mv over qb, and you look, we don't know the m, we don't know the speed, we know the q, we know the b. So this time we have two unknowns here. Obviously we can't solve it because we only have one equation. So we go to our other equation, voltage is equal to E over Q, or voltage is equal to 1/2 mv squared over Q. And in this equation this time we also have two unknowns. So this time you're going to need to sub one for the other. I would probably sub, maybe this V. So I would rearrange this because I want to solve for M. So it would be RQB over M is equal to V, the speed. And now I would take it and sub it in over here. So we would have V is equal to 1/2 M brackets RQB over M squared over Q. So V is equal to 1/2 M R squared Q squared B squared over M squared. And the Q on the bottom, dividing by a fraction, is the same as multiplying by the reciprocal. So that Q also stays on the bottom. Okay, so this Q will cancel that squared. This M will cancel that squared. So we'll have V is equal to 1/2 R squared QB squared over M. And we're trying to solve for M. So M will be equal to R squared QB squared. Instead of writing it as 1/2, I'm going to write it as 2V down here. And now I can fill in my numbers. R, they told us, was 0.077 meters, and that's squared. Q, 3.204 to the negative 19 coulombs. That is not squared. B, 8 to the negative 2 Teslas. That is squared. Divided by 2 times 156 volts. M equals. So now try to punch it in your calculator. 0.077 squared times 3.204 to the negative 19 times 8 to the negative 2 squared equals, divided by, what is that, 312? And you should get 3.8967 to the negative 26 kilograms. Checking the answer, 3 point, you gotta like it when you get it right. All right. So some good practice there using the V equals 1/2 mv squared over Q, perhaps connected to those of you that didn't use it on the last test. Okay, very good.